Hello, and welcome to Calculus Lesson 109. Today, we're going to find arc length of things that are not easy to find arc length of. And so, let me demonstrate with a picture. Suppose we have this curve here, and we want to find the length of this arc from point A to point B. So I want the entire length. If I were to walk this path, maybe measure it, drive along this path, measure it with my car, see how many miles I've traveled. We can do this using calculus. Now here's the general idea. Each little segment here, if I just wanted to find the direct distance from point A to point B, I would take some change in x, some change in y, and do the Pythagorean theorem. That would give me a good approximation, but it wouldn't be great, right? I missed this whole Boeing amount. So since this is calculus, what I'm going to do is I'm going to drop delta x to an infinitesimally small distance, and I'm going to drop delta y into some infinitesimally small distance. So we'll have delta x, delta y, delta x, delta y, delta x, delta y, and so on until we've added up all of these. And then obviously delta x is we're going to go as it gets infinitely small, and delta y infinitely small. So my distance should be the sum of all of these. So here's my distance equation, delta x squared plus delta y squared. So as I'm adding up an infinite number of these little triangle distance things, I know that when I have an infinite sum, that usually means I can integrate. So here's the trick. I'm going to divide this whole thing by delta x squared in the square root, and then multiply by delta x on the outside. That leaves the problem unchanged, right? I'm basically pulling out delta x from this, and I'm left with the sum of 1 plus dy by dx, or the derivative squared dx. And instead of sum, we know that an infinite sum can be written as an integral. And so this is the distance along an arc. You should write that equation down, memorize it. It is pretty cool. I love that we can find things like this where, you know what, we look at it and we're like, I don't even know where to start. And then using these fundamental principles that we already know, we can apply them to these much more complex problems. Next, we're going to find the length of y equals 7x plus 5 between the points A equals 112 and B equals 326. Again, I love that we take the building blocks and then we apply it to more complicated things. It's totally what happens when we take God's word, we hide it in our hearts, and then as we go through life, we figure out ways to apply that. We don't necessarily understand right away when we learn the Pythagorean theorem that we're going to find the distance along an arc of a weird function. But we have the skill, we have the ability, God has given us that, so then we can apply it to harder problems and harder issues. Here, I'm going to simply apply my formula. Distance is the integral from A to B. These are the x values of the square root of 1 plus the derivative. What's the derivative of 7x plus 5? Well, that's just 7 squared dx. So I have the integral from 1 to 3 of the square root of 50 dx, which looks like 2 square root of 50. Which, if I pull the 5 out, I get somewhere around 10 square root of 2. units. Simple enough. We could have computed this one using the Pythagorean theorem because obviously it's a line. So let's take one that we could not do so. We're going to find the length of the curve y equals x to the 3/2 from x equals 0 to x equals 3. First step, write your equation. Plug in. The derivative of x to the 3/2 is 3/2 x to the 1/2. Since we have x to the 1/2 squared, we know that that cancels each other out. So we have the integral from 0 to 3, the square root of 1 plus 9/4 x dx. From here, that looks a little wonky, but it's not an integral that we can't do. We'll do u substitution, the square root of u. So let's just do that. U is 1 plus 9/4 x. Du is 9/4. So I know that if I want to make this the square root of u, du, I have to multiply by 4/9. Not a surprise. Now the easiest way to do u substitution when you have balance is to plug those in. So I'm going from 1, and if I plug in 3, I get 1 plus 27 over 4, that's 31/4. That way, I don't have to deal with x anymore. I can just take the integral, which is going to be u to the 3/2 times 2/3 times 4/9, and evaluate that from 1 to 31/4. And that gets you the ugly answer of 31, square root of 31 minus 8 over 27. Ugly? Yeah, but units. That is the distance along that arc from 0 to pi, or 0 to 3. That, my friends, is problem set 109.